Welcome to another lesson on space. This time we're going under the hood to see what makes a space mission work. In this lesson, we'll explore space operations. These are all of the activities we need to get a mission off the drawing board, into space, and keep it going. Today we'll look at people-centered activities of running a space mission. Although technology forms the sections of the mission architecture we discussed earlier, mission management and operations pulls everything together. Mission operations include both people and systems that serve as the glue that holds all other elements together. It includes mission operations systems that are hardware and software, as well as mission management and operations, the people and the tool users. Here we'll examine the human equation to see how teams pull together to manage and operate missions from low Earth orbit to the farthest reaches of the solar system. Together, tools and people give us the ability to freely operate in space. Here you can see several of the hundreds of spacecraft working together to do their jobs in space. Here you can see the Space Shuttle STS-49 orbit team at Mission Control Johnson Space Center. This room full of people is just a very small part of all the men and women needed to make a successful shuttle mission. Mission management and operations refers to all the people and organizational activities needed to use the tools we just talked about to carry out a mission from concept to end, or cradle to grave, as the operators say. Let's look at this block diagram, which should be familiar to you. Remember earlier when we were talking about the systems engineering process? We learned the process goes through several steps, with each step drawing on design and analysis tools. The process repeats, and between each step in the process, loops take us back to review decisions in the previous step. Most important to managing a mission effectively is controlling the systems engineering process. One of the main purposes of mission management is to drive this process to achieve the highest possible performance with the least risk and time. We just saw in our systems engineering block diagram that the managers must define mission objectives, define and derive mission requirements and constraints, and define and draw from system requirements and constraints. The managers must also actively manage the requirements loop to trade off mission requirements and constraints, create analysis and design tools needed to decide among options, and establish operation systems needed to support the mission. An example of a design tool used at the Dryden Flight Research Center is this image of the HyperX vehicle at Mach 7 with the engine operating. Now that's some flying. Computer tools like these help engineers and managers sort through thousands of design options to make the best decisions without going to the huge expense of bending metal. In addition to all the things we've just mentioned, managers must actively supervise the design loop to trade off requirements and constraints while developing a final design. This process leads to overseeing the validation loop to make sure we pay for what we need and get what we pay for. Mission design and manufacturing teams get the mission started. These teams take the mission from a user's simply stated needs to a gleaming new spacecraft with all the necessary operation systems ready for launch. The student spacecraft design team shown here built a prototype of a rover to seek out life and water on Mars. Just imagine yourself as part of a team or a team leader on a spacecraft project. There are 8 major types of tasks that teams must do throughout the mission lifetime. In this lesson, we'll touch on a few of them, but they're all important and no task can be eliminated if the mission is to be successful. Take a few minutes to look at the major mission tasks and examples table in your text. Study each task and example and think about where you might fit into this big picture of mission management. Think about what your strengths are and what really interests you. Assembly, Integration, and Testing, or AIT, is a coordinated team effort by skilled technicians, system integrators, testers, and a group of engineers and scientists. All these folks are backed up by administrative support experts. Among some of the tasks the AIT group performs is screening components for form, fit, and function, assembling components to build subsystems, putting subsystems together to build systems, and testing subsystems and systems to make sure they work under flight conditions. Let's look at the AIT functions individually. During assembly, skilled technicians perform delicate touch labor to manufacture circuit boards and other critical components. Here you can see technicians assembling the Deep Impact spacecraft, which was the first spacecraft to attempt to peer beneath the surface of a comet. Part of spacecraft assembly is pulling together components into a completed system. Here an engineer does final integration of the FalconSat spacecraft. The FalconSat is the United States Air Force Academy's small satellite that is designed, built, tested, and operated by Academy cadets. Can you see yourself here? From the components to subsystems to entire spacecraft, testing is vital to make sure everything will work in the harsh space environment. In this photo, engineers are preparing the Advanced X-ray Astrophysics Facility spacecraft for thermal vacuum testing. Once inside the thermal vacuum chamber, the doors will be closed and all the air pumped out to create a vacuum condition like the satellite we'll see in space. Then, high-intensity electric heaters and liquid nitrogen cooling loops will alternately heat and cool the satellite to simulate the thermal conditions of orbit. The launch team's jobs start long before the spacecraft arrives at the pad. Their main focus is on two major tasks. The first is System AIT, or the integration of the spacecraft to the launch vehicle and doing a final checkout. The second is flight control, or monitoring the launch vehicle's telemetry and trajectory and sending commands that make corrections as needed to deliver the payload to the promised orbit. Here you can see the engineers and technicians during the final flight hardware checkout for the Apollo 17 flight. The Launch Readiness Review is a formal process used to make sure everything is prepared for launch. This is the last chance for everyone on the mission management and operations team to voice a go or no-go for launch. Every aspect of the mission, from initial design through manufacture and test, is reviewed and scrutinized to make sure there aren't any gotchas that could jeopardize the launch or mission. If everything is a go, we launch. Operations teams operate the spacecraft. The members of this team are also called flight controllers, the flight control team, or simply operators. The flight control team's leader is the operations director or flight director for space shuttle missions. The operations director coordinates input from other team members, and he or she must make the final decisions on what to do throughout the mission. Here you see a photo of Gene Kranz, who is one of the most well-known flight directors in the history of NASA. Gene was a chief flight director for more than 30 years, during which he managed the Apollo 11 moon landing, the Apollo 13 mission, and the Space Shuttle mission that repaired the Hubble Space Telescope. For fun, you might want to see the Apollo 13 movie where Gene famously declared, "Failure is not an option." True leadership, determination, and confidence in your support team can ensure that failure is not an option. Under the operations director, team members hold positions that follow the spacecraft's functional lines. Subsystem specialists are experts on the individual parts of the spacecraft. For example, one person may monitor the electrical power subsystem, while another watches the propulsion subsystem. The final members of the team are the payload specialists. They're responsible for the payload, its health, status, and operation. It's up to them to point cameras or antennas to collect valuable mission data. They process and deliver this data to users quickly and efficiently. You can see some mission operators at the Space Shuttle's Mission Control Center in Houston, Texas. But the job of the operators begins long before launch. Like a basketball team, to prepare for the big game, they must practice, practice, practice. Along with the astronauts for crewed missions, the operators rely on advanced computer simulations to give them a video game of the upcoming mission. But this is no game. Mistakes can mean life or death, so they have to be prepared to make the right decisions under intense pressure. Along with advanced computer simulations, Operators and astronauts depend on good old-fashioned book learning. That's right, studying doesn't end when you leave school. To prepare for a mission, they must learn every technical detail of their system so they know it like the backs of their hand. Once the launch vehicle lifts off, there are no timeouts or halftime breaks in the space business. Here you can see shuttle astronaut Tamara Jernigan practicing her on-orbit procedures by floating in a deep pool of water to simulate freefall conditions on orbit. While Tamara is learning the skills she needs, mission operators are practicing their ability to support her in the control center. For long or short-running mission operations, training never ends. Shuttle astronaut Piers Sellers says that you have to think of training like a marathon that could go on for many months or even years. Now look at this rare photo of a 1990 Department of Defense top secret mission. Can you guess what this training mission was about? It's actually astronaut J.O. Creighton training to ski in microgravity. Don't ask why. I have a feeling it's classified. Okay, we've looked at simulation and training, so now we'll turn our attention to flight control. Monitoring the spacecraft's telemetry and trajectory are part of the flight control process. Sending commands to make corrections or other adjustments to deliver the payload data to mission users are also the responsibility of the flight control team. Even for a relatively routine mission like the Global Positioning System or GPS spacecraft shown here, the operations team continuously monitors telemetry to make sure everything is working correctly, ready to send commands to address any contingency. Once the spacecraft is safely in its mission orbit, operators must verify that all subsystems are working normally during a period of on-orbit checkout, sometimes called commissioning. Years before launch, operators and mission engineers work out detailed procedures called flight rules. These flight rules provide detailed guidelines for how each subsystem should work and what to do during any possible event to save the mission.